Welcome back, my 7th grade advanced students. Let's go ahead and get this homework done. It's like I got the even ones tonight. First one says, what is the angle of rotation about the origin that triangle PQR, that's this one, the pre-image, to PQR prime? So I see that it's going counterclockwise, right? Because we know that clockwise is going like a clock. Counterclockwise would be going backwards. And when we go counterclockwise, that gives us a positive rotation. So we know it's going to be a positive number. And then we know that it's going about the origin, right? The origin is here. So if this was a clock, this would be exactly 90 degrees. We know that because every circle, right, is 360 degrees. And if we take 360 and divide it by 4, that leaves us with 90. So each one of these turns to a new quadrant will give us 90 degrees, okay? So this will be a positive 90 degrees, okay? So what is the angle of rotation? 90 degrees. If you wanted to, you could put 90 degrees counterclockwise, or you could just put positive 90 degrees, okay? 90 degrees counterclockwise. All right. I would probably go at 90 degrees counterclockwise. Honestly, this book is the first time I've ever seen a book classify a counter turn as a positive. So most of the time, other book authors make you say counterclockwise or clockwise. Either way, in this case, will work. Number 8 is my next one. A triangle PQR is rotated 270 degrees. Remember, every one of these rotations, right? And it says a positive, right? That doesn't say negative. So I know it's going in this direction, right? So this would have been at 90 degrees. And coming over here would make 180 degrees. Then coming over here would make 270 degrees. Okay, and now we have to turn this all the way around over here. This is almost like really turning this thing 90 degrees, negative 90 degrees or 90 degrees clockwise, all right? So we have to see, we're literally taking this whole shape here, and I'm going to shade it in with my highlighter, taking this whole box here, and we're actually turning it, okay? The whole thing. So if I did that, that would mean this, if I turn this whole thing this way, right? Well, think about it. If I turn it this way first, then this would be on the bottom, right? And if I turn it again, this would be over here. So when I turn it again, this is actually over here now, okay? So we have to keep this equal distance. It's 2 away, right? And it started at 3. So over here, I would go to, I'm sorry, started at, yeah, 3, 2 and 3. So over here, it's going to be, let's see, 3 and 2, about right here. Okay, that would be P, P prime. And now we're taking R, which is 2 and 7. So that would make this negative 2 and 7. We see how this over here, the y-axis, is now becoming the x-axis over here, right? And now the last one, Q, was at 4 and 6. So I would go to negative 4 and positive 6. So now when I connect my lines, I'd have a line going from here to here, a line going from here to here. I'm connecting my coordinates, excuse me, not my lines. And my new triangle would be here, with P prime being here, with Q prime being down here, and with R being up here, R prime, excuse me. And that would give me my new triangle, PQR prime. All right, let's go ahead and go to, let's see, that was number 8, that means I have number 10. Explain why any rotation can be described. Explain how any rotation can be described by an angle between 0 and 360. Explain how it can be described by an angle between 0 and 360. And I'm sorry for being a little lazy here, but instead of typing all this, I'm just pasting the definition. After 360 degrees, you are just repeating multiples of degrees between 0 and 360. For example, a 540 degrees is the same as 180 because 540 minus 360 equals 180. Okay, so this is a sample answer. Basically, what we're saying is when you're dealing with a circle here, okay, there's only 360 degrees to work with all the way around, all right? So from one point to the next is 360. Once you go past 360 once, and I'm just going to use a highlighter to show me going through this once in yellow. You're taking whatever measurement you got and so adding it to 360. So 540 in this case would be another 180 across. So you've got the full rotation of 360 plus another 180. So when you travel, what they're saying is when you travel all the way around to 360 and then you go that additional 180, you're actually going to be right here, okay, at the 180 mark. Okay, let's see, I got number 12. High order thinking question. On number 12, it reads, an architect is designing a new windmill with 4 sails, okay? In her sketch, the sails' center of rotation is the origin, 0, 0, and the tip of one of those sails has Q, has a coordinate of 2 and -3. She wants to make another sketch that shows the windmill after the sail has rotated 270 degrees about the center of rotation. What would the coordinate of Q prime be? I'm going to use this over here as a little sketch. Remember, they're saying that Q, the pre-image, is going to be at 2 and -3. So 2 would be here and -3 would be here. All right. So if this was a windmill, we might say, and I'm not sure how she's making her flaps, but we might say, let's see, her sketch, origin, the tip. It doesn't say if the windmills are squares or if they're triangles. I'm just going to put as a triangle here because it doesn't matter. We're only looking for Q. All right, let's just say this is the windmill. All right, and this point here is Q, pre-image. We're looking for Q prime, okay? Now they're saying after the sail has rotated 270 degrees, notice it doesn't say negative, okay, which means we're going counterclockwise whenever they say that it is a positive rotation, all right? So the first rotation, which would be 90 degrees, would put our, remember this now becomes our X. So this is going to be here, here, and here, right? So that's at, and I'm going to make all of these a different color. So this windmill here, this flap of the windmill is going to be at, oh, hold on, I wanted it a different color. There we go. This one now will be here, here, and here. Does everyone see how this totally flipped up over here? Which means the next image, and I'm going to make this one, no, how about yellow? All right. The next image is going to be here, here, and here. And so the last image, which I will put as green, is going to be here, here, here. Now this is going 270 degrees because this, turning it here to here, and let me change my colors back, would be 90 degrees, right? Then this would be 180 degrees. So bringing it to quadrant 3, right? This is quadrant 1, 2, 3, would put us at 270 degrees. And this would be our Q prime then, right? Q prime would be right here. And you'll notice that's going to be at -3 and -2, okay? -3 and -2. This should have been no surprise because in our lesson, we did realize when we rotate 90 degrees, okay, we change, and you're going to use an example here. When we move it 90 degrees, we change it to our -3 comes over here, right? And it becomes a +3. And then our 2, okay, moves over here and stays at 2. Since we're moving it counterclockwise, right? We're seeing that we're going to take our second one here and bring it over here, which will become negative still, right? Because this is still going to be a, yeah, this is still -3. So now x is -3. And now this becomes a -2, where before it was a +2. So our coordinates should be -3 and -2. All right, guys. I don't have any other ones, so that was it. Good luck with the rest of yours, and I'll see you in class to grade all the rest of them. All right. Have a good night.